TTL Computer 2. Today we're going to be testing our memory card. And as you can see, we already have this in our jig and powered up. And just briefly, we have switch number 1 is wired as our to our data bus. Part of switch number 2 and the first nibble of switch 3 are controlling our address bus, and then our last 2 bits on the switch are used for our not read signal, which is active low, and our write signal to for our memory circuits. And just as a refresher, we have two memory elements on this card. We have our low memory that is for our ROM, and the upper 32 bits, 32K bytes is for our random access memory. So that's the memory that's on our card. And I mentioned on our community pages, I've already also patched posted the jig patch diagram, so you can have the specifics there to look at. But one of the things I mentioned when I also posted the test plan is that one of the complications here is that our address bus, we're using it in a bidirectional fashion for our testing, right? It's for this card, we have data coming in on the data bus and data being read is being read out on the data bus. So we have a two-way data transfer, and our jig isn't really designed to handle that directly. So what we're doing is we basically have our output display and our input elements for our data bus wired to a breadboard, and we're essentially putting those in parallel and making a little data, joining them together to make the bidirectional data bus. But we need to be really careful that we when we are using we're reading from the card, that our data bus switches are all off, or else we have the potential for bus contention and some short circuits, and we obviously don't want to do that. So we have to be really careful, and that's part of the reason why I'm going to give you again. Here's our test plan. Again, I posted this to the community pages, but you see we have our check marks here, indicating that I really have run through this test before this video, and I really need to do that independent from the videos, because I really need to give my full focus and attention to the test plan so that we don't make a mistake and introduce again, have the wrong setup, and then have the potential for short circuit connections, and we don't want to do that. So what I'm going to do here, so I have gone through the test plan, and our memory card has passed. But what I'm going to do is I'm going to just go through some of the elements. So yeah, again, just to give you a flavor for how the testing proceeded. Okay, so we're gonna just start this testing now. And first thing I want to do is make sure that our initialization is all correct. So our data bus is all low, our address bus is all low, our read is high, which means it's that's active low, so that's disabled, and our write signal is also low, which is disabled. So we are ready to we pass that initialization. So now we're ready to begin. First thing we're going to do is a ROM test. Now I already burned into our ROM our digital simulation regression test program. So that's loaded in there. Okay, so this is actually the hex file that's for our regression test program. And what I've done here is, and again, our hex file takes it's just it's a specific output from the assembler. That is the format that we use to burn to our EEPROMs, and it's really just an ASCII file. And what I've done here is I've identified specific addresses and recorded the binary data values for each of those addresses. So we are going to use those addresses and the values obtained here to do our read test of our ROM. Okay, so we're going to just start out. Our first read test is going to be with address 0. So again, we have ensure our data bus is 0, our address buses are 0, and we are going to bring read low now so that we can enable the output from the ROM. And for address 0, the first byte of our ROM file is 0, so that's confirmed. All right, so I'm going to mark this off on our test plan. All right, so now we're going to go to address hex 0020. 0020. Okay, so that's for hex address 0020, and our value should be hex 2, and that is a hex 2, so that passes. And our next address is going to be hex 0080, and that value should be 3C, and that's in fact what we have, 3C. And that's a pass. And our next address is 0100. And that should be 5. And it is. And our next address is 0300. And the data from our ROM is 07. And that's what it is, 07. So that is a good ROM read test. We want to bring read bit back, control bit back high. Okay, and then we can just do, just going to do a brief write test. And we want to use address 8000, which is the beginning of our RAM. We want to put 80 hex on our data bus. Write enable, we want to bring that high, and we want to do uclock to clock that in. Okay, so we did that. I'm going to bring write back low, and let's see. We want to bring, let's do this. Let's make our address be, we'll change our address. And let's go to read. And we just have garbage in there because it's that address hasn't been written to. So let's change the address now back to 80. And there's the hex 80 that we wrote to our RAM. Okay, so we went through and we did a bunch of read tests to our ROM, and those were all good. And we just did a simple write test to our RAM, and we validated that was good. Okay, so we're still in read. We could just take a look at some of the other addresses real quickly just to see what we have. It's just going to be garbage, random data in our ROM, and come back to hex 80 address, and that has our hex 80 that we wrote in there, and that is good. And I'm going to turn the reads off, and we're back to a floating bus like it should be. Okay, so that was just a flavor for how the testing went. And again, our test plan is posted on the community pages. And but this was a successful test of our memory card. So that leaves us with 2 cards left to go. And our next card that we're going to be implementing will be our ALU. So that's it for today. Until next time, thanks for watching.